is number 23. Okay, and number 23 has a lot of information that's given in the problem. It's asking you to find the heat of formation for HCl gas. And you're given some information. You're given the HCl bond enthalpy, which is the bond energy. The bond energy is positive 431 kilojoules per mole. And you're asked to find HCl formation. So all you have to do is write the equation for HCl. So this is the equation to make HCl gas. In this here, you're going to make HCl, which has a single bond here. So you're going to make one of these bonds here. The energy to break the bond is 431. Instead, you are making the bond. Since you are making the bond, you take the negative of that value. So it's going to be 431 kilojoules per mole is going to be the energy to make HCl. Now, on the answer key, it's asking you for kilojoules per mole. Oh, that is weird. So the energy, so the answer should have been negative 431 kilojoules per mole here for this problem. Said the answer was something else though. So if you put this answer, I will give you points for that one. Yeah, it said it was wrong, so I apologize that. Yeah, the answer key is incorrect on that one. Okay. Number 40, I think 40 is okay. On number 40, all right, on number 40, it says, what is the temperature change when 19.3 grams of NaOH with a 44.5 kilojoules per mole energy released, that when it goes into solution, it's dissolved in 120 grams of water, and assume the specific heat capacity of the solution is 4.18 joules per gram Kelvin, which also equals joules per gram degree Celsius, because a Celsius degree is equal to 1 Kelvin of temperature difference. So the first thing we have to do is convert the 19.3 into moles. Once you have the moles of this, then you can solve for the kilojoules using 1 mole is proportional to 44.5 kilojoules being released. Okay. So that will allow you to solve for the kilojoules. So to do this, we take 19.3 and divide it by 40. It says 40 grams per mole. This equals 0.4825 moles. Multiply that by 44.5. This gives us an energy value of 21.47 kilojoules. Now, this heat is going into the solution. In the solution, we have 120 grams and 19.3 grams. So we use our Q equation for the solution. The Q for the solution is equal to the mass of the solution, which is 120 plus 19.3, or 139.3. The specific heat capacity is the 4.18 joules per gram degree Celsius, and the thing we don't know is the change in temperature. The heat was 21.47 kilojoules, 21.47, and if you convert that into joules, this is 21,470 joules. So that's equal to your Q value. Now you just need to solve for the delta T. So you take the heat divided by 139.3 and then divided by 4.18. And the change in temperature for this particular problem, sorry, running out of room, should be a 36.87 degree Celsius change. So let's check on that. 36.8775 is what the answer key said. Does that make sense, Chelsea? So on this one, it was a little tricky because it was talking about the solution, not just the water. So that's why you had to add the sodium hydroxide to the water mass, because both of them influence the rate at which it heats up. All right, next problem on 24 for the fire. Okay, on the 24 for the fire, this one here is using heat of formation information. This is one I've been asked a couple times, so it would be helpful if you didn't get this or you're unsure how to do it. You want to pay attention here. This is asking for the enthalpy change, which is the same thing as heat of reaction under normal conditions. PbO plus CO makes Pb plus CO2. The information you have is the heat of formation data, and so to find the delta H from this, you just write in the data you have. This is negative 217.3 kilojoules. Since there's only 1 mole, I just multiply this by 1. Then the CO data is negative 110.5 kilojoules per mole. And then the PB data, lead is already a compound. So heat of formation is always elements forming compounds. If you have an element forming an element, it's going to have 0 change in its heat. So elements forming elements mean they're already an element. You don't have to add or remove heat to change it, because there's no change. The CO2 is negative 393.5, and again, there's 1 mole of it. So these are the values you have for this equation. These are all for heat of formation. So CO2 is the one that's getting formed. PbO and CO are not forming, they're doing the opposite. What's the opposite of forming? Deforming or breaking apart. So these are breaking apart. So since these are breaking apart, the sign changes from the negative to the positive, the opposite sign. And then this one here is still negative 393.5, and you just add all of these together to get your delta H. So it should be a fairly small negative number. So this is how to use heat of formation data to find the heat change in a reaction. For number 35, so for number 35, you've got some sort of mass of silver. This is 29 grams in this example. The first thing you do is convert it into moles. So there's 64.1 grams in 1 mole. The amount of moles is about 0.452418 moles. And then you just have to convert that to kilojoules. And in 1 mole there is, according to the problem, 296.8 kilojoules. So that's 296.8 kilojoules. You cross multiply these two, and the amount of kilojoules is equal to 134.278 kilojoules, and that's the amount of energy given off. So that is number 35. Let's see what else we have. Any other good ones? All right, for the next problem, number 44. For this here, you're starting at a temperature. You got 39 grams of water. It's starting at 20 degrees Celsius. It's ending up at 127. So if we draw a graph of this, heat is being added. Starts at 20 degrees Celsius, that's liquid water. It ends up at 127, that's gaseous water. So it's somewhere in here it has to go through a phase change. The point at which it changes phase is 100 degrees Celsius. So this is a temperature change, a phase change, and a temperature change. So this is step 1, this is step 2, this is step 3. For step 1, we use our Q equation for the liquid. For step 2, we use our delta H equation, which is the heat of vaporization times the mass. And for step 3, we use our Q equation for the gas. Now, all of the data is given in the problem. You plug in the numbers, and this is going to give you a joule value for each of these quantities. You add all three of these up, and that tells you the total amount of joules for this three-step process. Once you add together the three steps, your answer is in joules. The answer key wants it in kilojoules, so the last step is to divide by 1,000 to get it into kilojoules, and that would be your answer. The thing that's tricky about this is the specific heat capacity of the liquid is 4.184. The specific heat capacity of the gas is 2.03. The mass is always, in this case, 39 grams. 39 grams. And this is 39 grams. And then the change in temperature is all you have to find. For step 1, it goes 20 to 100, which is 80. For step 2, it is the heat of vaporization, which is also given as 2260 joules per gram. And the delta T on the last one is 27. So that's all you have to do. Multiply those out. I'm not going to go through those multiplication steps, but that is sometimes a source of error on those problems. Okay, how many people would like to move on to the smells questions that are up here? A bunch of those, all right. What's up? Oh, showtime, sorry. What did I say, smells?
Yeah.
All right. Sorry about that. All right, let's look at the smells, question number 3. Showtime. We'll get to showtime sometime. All right, showtime, question number 3. Not easy, I apologize. 2y making z. What you have to do is look at the initial concentrations of X, which is 2 molar. The initial concentration of X in another case is 4 molar. All right, on this one here, because the initial concentration is greater in situation 2, because you have more to start with, that means the final concentration of Z will be greater because you will lose more from it due to the equilibrium process. So because the initial concentration is greater, that's why the correct answer would be ZEQ is greater under conditions 2 than conditions 1. And that's assuming everything else stays the same. If the concentrations were both the same, they would both have the same amount of product for these two reactions. All other things have to be equal, yep. So you could have also, this is what is called an ice table. You can always use this to see what's happening, initial, change, and equilibrium. This question I do not like. I apologize that it's still on there because it's not super clear with what's happening, and you're dealing with initial concentrations, not equilibrium. We will focus mainly on equilibrium concentrations. All right, if there's other questions you have, you're more than welcome to stay. I'll go through any of these on the screen. Yep. 22 on Showtime? I'll do 22 on smells just for fun too later. All right, 22. All right, so 22. All right, you've got 2 HGO solid at equilibrium with 2 Hg liquid plus oxygen gas. First thing you'll notice is we have K is equal to O2 concentration. This is solid, this is liquid, they don't affect it. So the equilibrium is based on the oxygen concentration here. The options are the partial pressure of O2 will increase. So adding more HGO, you're adding this. If you're adding this solid, it's not going to change anything about the equilibrium. So number 1 is false. Number 2, O2 will increase, Hg will increase, and HGO will increase. Okay, that is also false. It doesn't affect the equilibrium. Number 3, the amount of Hg liquid will remain unchanged. That might be right. That's the only one that is Hg stays the same. You're not going to change the amount of Hg because this does not affect the equilibrium. Only oxygen concentration would. So the amount of Hg will decrease. No. 5, the amount of Hg will no. It's got to stay the same because of the K expression. The liquids and solids are not included at a heterogeneous equilibrium. Yep. Next. I can show you where it currently is at. We also have your fire lab to put in, which might raise the grade. That's where we're currently at.
What do I need to get on the test amount or the pass? Like I'm turning in all the extra credit to Showtime and all that stuff.
Well, it looks like we've got 6. Oh no, it's going to be a larger percentage for you, so that's going to be I don't know. That says about 80%.
Okay. To pass the class? Even with all the stuff turned in?
Well, the stuff turned in will obviously help, but that's without any of the stuff turned in.
So I need to get basically, that's not going to happen. I've never gotten an A on your test before. Like, yeah. And is there anything else you could do to bring it up? Like for Colorado, we use so
They won't go to college and practice.
Yep, you need to study for the final so that you can pass the
We're
final.
gonna study like all day.
yeah, we have a study group
And then
too.
like we're planning on at least getting a C, but like like a B is like kind of out of reach. Like we've never gotten a B on any test.
That's what we're going to need to do. So at least mathematically, that's what it looks like. Your final counts for more than the tests you've taken so far.
And will there be a curve on it?
Curve on the final, there is probably, I think it's about a 90%. And it's all multiple choice. It's similar to the quarter one final in terms of the layout. So same type of questions and stuff like that. So you get the star practice questions, those
Is
test
that
questions.
the 100? So there's like a problem test of it, and 100 problems. Is that the star one?
Don't know. Lots of practices online.